Hi, this is a lesson for Year 10 Higher Mathematicians. It's week 10. The topic is Pythagoras' theorem, and this is lesson 28, Pythagoras' theorem problems 1. Now, I'm not going to go over finding the length of the hypotenuse and finding the length of one of the shorter sides. I'm more interested with these problems in going over where Pythagoras' theorem perhaps is used with other topics in maths to solve the problem. So with this example then, we want to find the area of the triangle. So we know that if we want to find the area of the triangle, a fairly good place to start would be area is equal to half of the base times by the height. Now, the base we have here as 10.2. We have a height, but this is not the perpendicular height. The actual height of the triangle that we want, if we're going to use 10.2 as the base, is this value here. Okay, the height at right angles to the base. The question is then, how do we go about finding out the height of the triangle? What we need to do is essentially use Pythagoras' theorem to find the length of a shorter side, which we can then use to find the area of the triangle. So how are we going to do this? Well, I've already said that the height we're interested in is the perpendicular height to the base. In other words, that needs to be a right angle there. The question is, how do we know that is going to be a right angle in this particular case? Well, because it's isosceles, okay, that's what these two sides mean. These two symbols mean here that these sides are both the same length. We know it's isosceles, therefore we know if we draw a line, split it down the middle, that one triangle will be a reflection of the other. Okay, in other words, and this must be 90 degrees. So what we can actually do is create a right angle triangle from the isosceles triangle that we can then use Pythagoras' theorem with. Well, we know this is 13.7 as well, centimeters. And we also know is that because this base has been split in half, this side length here must be 5.1 centimeters. So now we are able, using Pythagoras' theorem, able to find x. So we know that 13.7 squared must be equal to x squared plus 5.1 squared. Therefore we know that 13.7 squared take away 5.1 squared equals x squared. Therefore x squared must be equal to 161.68. and x must be therefore equal to the square root of 161.68. X must therefore be equal to 12.72. Okay. Now all we need to do is put this value into our formula here for the height. So we know that area must be equal to a half times by the base. Remember, this is the base of the full triangle here. Okay, so that's going to be 10.2 times by 12.72. Okay, remember on your calculator use the full value here with all the decimal places shown. We only ever round the final answer properly, and that should give me 64.85 centimeters squared to 2 decimal places. Now the next example I'm going to show you, again, it's the question is find the perimeter of the shape. At this stage there is no hint as such that Pythagoras' theorem is required, but what we do know is that we are presented with this shape, and to find the perimeter what we essentially need to do is add together this side length here, this side length, and this side length here. Okay, so it's this one here that we need to be able to find. Now, how are we going to do that? Well, what we can do is, if we split this problem up into two right-angled triangles, okay, much like that. We know that if we find length x and we can find length y, then if we take y away from x, we will end up there with z. Now we are missing just a bit of information, but again, what's useful is that we've been told that these marks here mean that this side length is the same as this side length here. Therefore, if the whole thing is 8, this must be 4 centimeters. And this one must also be 4 centimeters. Okay, so what I'm going to do is then, I'm going to find out the length x first. Okay, so x squared must be equal to 10.5 squared take away 4 squared. Remember, x is going to be the shorter side of the red triangle, where 10.5 is the hypotenuse. So I need to do 10.5 squared take away 4 squared. That gives me x squared is equal to 94.25. X is equal to the square root of 94.25. X is therefore equal to 9.70 something or other. Okay. Now I'm going to do the same for to find y now, similar thing. So y squared must be equal to 6.7 squared take away 4 squared. Y squared must be equal to 28.89. Y must be equal to the square root of 28.89. Therefore, y is equal to 5.37. Now, to find z, what we know that we need to do is to take away y from x. So z is going to be equal to 9.7 whatever, take away 5.37, okay, which gives me an answer of 4.33 centimeters, and remember that is to 2 decimal places. However, at this stage I still haven't answered the question. The question says find the perimeter of the shape. So I have found this missing side length here, but to find the perimeter I'm going to have to add all of these values together. So I'm going to start here with z, which I know is 4.33, add 10.5, add 8, add 6.7, add all those measurements up, and you should end up with a perimeter of 29.53, again to 2 decimal places, which is the final perimeter of the shape.